Hello all, welcome to the day 66 of the daily case study series for CBSE grade 10. The question goes like this. In a class 9 mathematics lesson, the teacher drew two circles that touch each other externally at point M. The centers of the circles are A and B and their radii are 5 cm and 4 cm respectively as shown in the given figure. In the given figure, there are two circles. One is bigger circle with center A and the radius is 5 centimeter, and a smaller circle with center B with radius 4 centimeter. These two circles touch each other externally at the point M. Also for the bigger circle, there is a point P outside the circle. From that external point, there is a tangent PS to the circle which touches the circle at S. Similarly, for the smaller circle, there is a point Q outside the circle. The tangent from Q is QT and it touches the circle at the point T. Based on the above information, solve the following questions. Question 1. Find the value of Px. Px is a part of AP which is in the bigger circle. So let's consider the bigger circle. Join A and S. AS is radius. PS is a tangent. Therefore, this angle ASP is 90 degree. The reason being radius is perpendicular to the tangent at the point of contact, which implies that this triangle ASP is a right angled triangle. By Pythagoras theorem, AP is equal to square root of AS square plus PS square, which is equal to square root of 5 square plus PS is 12. So 12 square, which gives us root 169, that is 13 centimeter. Px is a part of AP. Px is AP minus AX. AP is 13 and AX is 5, which gives us 8 centimeter. Question 2. Find the value of QY. QY is a part of the smaller circle. So let's consider the smaller circle. Joining B and T, BT is radius and QT is tangent. Therefore, this angle BTQ is 90 degree. The reason being radius is perpendicular to the tangent at the point of contact, which implies that triangle BTQ is a right angled triangle. Applying the Pythagoras theorem, BQ is square root of BT square plus QT square, which is root 4 square plus 3 square. This gives us 5 centimeter. QY is a part of BQ. We have got the value for BQ. QY can be written as BQ minus BY. Here BQ is 5 centimeter and BY is the radius which is 4. So it is 1 centimeter. Question number 3. Show that PS square is equal to PM into PX. PS, PM, PX. All these three lie in the bigger circle. So let's consider the bigger circle to solve this question. In triangle ASP, by Pythagoras theorem, PS square is equal to PA square minus AS square. If we observe the statement to be proved, this PM and PX both lie on the segment PM. So let's replace AS with AM. So this can be rewritten as PA square minus AM square. Using the identity A square minus B square, the right hand side can be written as PA plus AM times PA minus AM. The first bracket PA plus AM. So if we add PA and AM, we get the line segment PM. So we got one quantity in the right hand side. The second one is PA minus AM. Instead of AM, let us write AX. That is from PA, if this AX is removed, we get PX. We have proved that PA square is equal to PM times PX. Hence proved. Question 4. Show that TQ square is equal to YQ times MQ. TQ, YQ, MQ all lie in the small circle. So let's consider the small circle for solving this question. In triangle BTQ. Applying the Pythagoras theorem, TQ square is QB square minus BT square. If we observe the statement to be proved, we have YQ and MQ on the RHS. YQ and MQ lie on the line segment MQ. So let's replace this BT by BM. So TQ square becomes QB square. Instead of BT, we write BM square. Applying the identity A square minus B square, this can be written as QB plus BM times QB minus BM. QB plus BM gives the entire line segment MQ. And in the second bracket, instead of BM, if we replace that with BY, from QB, if we subtract this portion BY, then we get the YQ. So the RHS becomes MQ times YQ. So here we have achieved the RHS, hence the statement TQ square equal to MQ times YQ is proved. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.